the things you remembered about the lesson that we discussed the other time.
We discussed about uh, universe,
What else?
galaxy,
Mm-hmm. And
and galaxy, and about uh,
okay, what about life cycle?
yeah, life cycle and plants.
Yeah, okay. So now let's just continue our topic about um, the universe. I guess we stopped here in the universe, right? Okay, so now, Lee, we are going to talk about the universe. Okay, our universe is everything there is. We have the galaxies, stars, planets, moons, and even space and time. And the universe is, I'm sorry. Okay. So the universe is so incredible and vast that it is difficult to fully understand it. So we on planet Earth are just one tiny speck in the universe, and it will perhaps always remain a mystery to us. Okay. So this is George uh, Lemaitre. In 1927, Belgian astronomer George Lemaitre was the first person to suggest the universe started with a big bang, which is the Big Bang theory that we discussed last time. And at the time, few astronomers believed him. Okay, so um, in his time, in George's time, it's only few astronomers believe his theory about Big Bang. Okay, while the next uh, here is the Hubble Space Telescope. So this spatial telescope has taken hundreds of pictures of space. So inside one tiny dark patch, astronomers found 10,000 distant galaxies, and each containing hundreds of billions of stars. Okay. So, can you read what happens nextly?
Mm, nobody knows. What we do know is that the universe is still expanding. If this continues, it will eventually become even colder and darker.
Okay. So, here, say for example, this is the galaxy. So, galaxies are pushed apart as the universe expand. Okay, so this is the galaxies. So they pushed each other away to each other. Okay, so here, 500 million years old. So the stars were pulled together by gravity into collections of hundreds of billions of stars. This is to form the first galaxies, including our own Milky Way. So, have you heard? There is a song about Milky Way, but I don't remember the title. Anyway, let's continue. 13.8 billion years old. Today, the universe is still expanding, and it is a vast collection of galaxies, gas, and strange things we are still trying to understand. So, until now, Lee, um, most of the scientists still have these things that they cannot fully understand yet. So they are still searching and searching and searching for some answers of their many questions. So next, we have birth. So each stage of a star's life cycle takes place over billions of years, and all stars are born from giant gas and dust clouds called nebulae. Okay. And then gravity pulls the gas and dust together to form hot spinning clumps. So this is. So young and bright. Over time, these clumps get so hot that nuclear reaction starts inside them. And they turn into what?
Stars.
Stars. Very good. And the intense heat makes them glow. A young star is called a protostar, that means early. Proto means early. If we compare that to human, that is what? A kid. Okay, next. Next cycle is death. The planetary nebula drifts away and is scattered into space, where it will in time form new stars. All that is left of the star is the glowing core, called a white dwarf. So this is it. And this gets smaller until it cools and becomes a black dwarf. Okay. So what is the cycle of the star? First, its birth. Next, young and bright. And after that, it will die. Okay, so just like animals, stars are born, grow and develop through life, and then die. Depending on its type and size, a star can live and die in different ways. Bigger stars shine more brightly but live shorter lives than smaller stars. This is the life cycle of a medium-sized star. Okay. So look at this, Lee. If this is the sun, okay, so this is a medium-sized star. So do you believe that a sun is a star also?
Oh no.
No, okay. The sun is a medium-sized star and will follow the same life cycle as the one above. The sun formed about 4.6 billion years ago and is presently at the main sequence stage. In about 5 billion years, it will die. Okay, so imagine that after 5 billion years, we don't have sun anymore. And look at this. According to this book, the sun is a medium-sized star. So a sun is also a star. Okay. Next, kindly read this, Lee.
Black dwarf. Stars die in different ways. Medium-sized stars become dark, dead blobs called black dwarfs. Bigger stars collapse into themselves completely. They turn into black holes. Here, gravity is so strong that no light can escape.
Yeah. So this is a black dwarf. Stars die in different ways. So medium-sized stars becomes dark too. Okay. So here, dead blobs called black dwarfs. So look at this. This is one of a black dwarf, and bigger stars collapse into themselves completely. They turn into black holes, and here gravity is so strong that no light can escape. Next, getting bigger. So after billions of years, the star runs out of hydrogen and its core. The star expands to a huge size, and the temperature of its outer shell drops, causing the star to glow red. It is now called a red giant. Okay, so have you seen a star that is like this color?
Not yet.
Not yet. Okay. But yeah, it's possible there is a star that can reflect like color reddish or red orange. Okay. Some middle years. Gradually, the star gets even hotter and shines brighter. As it heats up, the gases, including hydrogen, ignite and start to burn up. The star spends most of its life at this stage. And this is called the what, Lee? Main.
Main sequence stage.
Okay, so the main sequence stage. And lastly, fading and dying. Once all the fuel is used up, the outer layers of the red giant start to fall away. This glowing cloud of material is called a.
Planetary nebula.
Okay, next, heating up. A star's color depends on how hot it is. The hottest stars produce a blue light, cooler stars have a reddish orangey light, and it is possible to see these different colored stars if you look at the sky through binoculars on a clear night. So, do you know what is a binoculars?
Uh, yeah.
Okay, so this is an instrument like a telescope that you can use to watch the stars at night. Okay, so here, this is the hottest and this is the coolest. Starts with a blue. This is for 80,000 Fahrenheit or 45,000 degrees Celsius, while blue white is 55,000 Fahrenheit, or 30,000 degrees Celsius, while white is 22,000 degree Fahrenheit or 12,000 degrees Celsius, and yellow and so on until red it's only 6,500 degree Fahrenheit or 3,500 degree Celsius. So can you read this, Lee?
Yellow white is 14 uh, 14,000
Degrees
degrees or
Fahrenheit.
Fahrenheit or 8,000 degrees
Celsius.
Celsius.
Very good. Next, yellow.
Yellow is 12,000 degree Fahrenheit or 5,000 degrees Celsius.
It's 6,500 degrees
Yeah.
Celsius. And last, orange.
Orange is 9,000 degree Fahrenheit or 5,000 degrees Celsius.
Very good. Okay, so now let's talk about how the sun is born. So kindly read this, Lee.
The sun is born as the cloud collapses due to gravity. Its center starts to heat up. It eventually becomes so hot that hydrogen atoms combine to make helium in a process called fusion. This releases a huge, huge amount of energy, and a hot, shining star was born, the sun.
Okay, so the sun is one of the hot shining star. So do you know what is a helium?
Yeah.
Okay, so this is uh, one of the um, what element. Okay, one of the element that needs to fly a balloon.
Yeah.
Okay, so have you seen a balloon that can fly up in the sky?
Yes.
Yeah, so inside that is an air called helium. Okay, because if you just blow a balloon, just put an ordinary air, it will not or it cannot fly. However, if you use helium to put inside the balloon, it will rise up. Okay, so next, some of the lightest gases spun around the cold outer edge of the disk. So, say for example, this is the sun, and then this is the outer part. So it's cold, and uh, it spun out of the cold outer edge of the disk. This means it's a round shape. Okay, so look at this. And then planets forming. Can you read this, Lee?
Material from the cloud began to form planets. Close to the sun, gravity pulled bits of dust together into clumps to form rocky planet. Far away, where it was cooler, gases came together to form enormous planets called gas giants.
Okay, so it's called gas giants. So planets forming, material from the cloud began to form planets. So those materials that can be seen in a cloud that used to form planets. So close to the sun, gravity pulled bits of dust together into clumps to form rocky planets. And farther away, where it was cooler, gases came together to form enormous planets called gas giants. Okay. Actually, there are many planets, but the very well known planets that we have in our Milky Way is just the 8 or 9 planets. It's, I guess, eight. Two, four, six, eight. Okay. Do you know before that this is 9 planets?
Yeah.
Okay. What is the ninth planet?
Yes. Saturn. Venus.
Mm, nope. Actually, there is the last planet is called Pluto.
Oh, yeah.
Yeah, but now they just acknowledge the eighth planet. I don't know what's the reason behind that, but when I was in elementary grade and when I'm in high school grade, we studied 9 planets, but actually, now they just acknowledge eight. Okay, so the eighth planet that we have is Neptune. Can you read this, Lee?
Jupiter. Earth. Mer- Mercury.
Mercury.
Mercury. Mars. Uranus. Saturn.
Yes, and Saturn. Okay, so the closest planet in the sun is called Mercury. And the second one is Venus. So there is a song Mercury, Venus, and Earth. Earth is the third planet. Mars, Jupiter, and Saturn, Uranus, Neptune, and um, next to Neptune is Pluto. But Pluto is not included here. Okay, so our solar system. Can you read this, Lee?
Our solar system. It took tens of millions of years for the planets to form our solar system. Mercury, Venus, Earth, and Mars are rocky planets. and Jupiter, Saturn, Uranus, and Neptune are
Giants.
gas giants. Between Mars and Jupiter is an area called the asteroid belt.
Belt.
This contains many smaller dwarf planets, as well as small rocky asteroids.
Yes, okay. So our solar system is composed of the 8 planets. Okay, so it took tens of millions of years for the planets to form our solar system. Mercury, Venus, Earth, and Mars are rocky planets, and Jupiter, Saturn, Uranus, and Neptune are gas giants. So between Mars and Jupiter is an area called the asteroid belt. So here, between what planet is that? Uranus and Neptune. So here, Uranus and Neptune. So between these two planets is called the asteroid belt. Okay, and this contains many smaller dwarf planets as well as small rocky asteroids. Okay, so like what I told you earlier, there are lots of planets, but the um, the planets that are acknowledged in is in our solar system is only 8 planets. Okay, next we have dusty beginnings. Can you read this?
Dusty beginnings. About 4.6 million years ago, a cloud of dust and gas began to fall in on itself. At its collapse, it started to spin, forming a dense disk shape.
Yes, okay. So Dusty Beginnings, um, this is about 4.6 billion years ago. A cloud of dust and gas began to fall in on itself. As it collapsed, it started to spin, forming a dense disk shape. Okay, so next we have Goldilocks zone. Can you read this, Lee?
Uh, z- Gold, Goldilocks,
Goldilocks zone.
Goldilocks zone. This is the area of our solar system where water and life can exist, like the porridge,
Porridge.
porridge that Goldilocks is. The conditions are perfect. It's neither too far from nor too close to the sun.
Yes, okay. So this is the area of our solar system where water and life can exist. So meaning that's the Earth. Like the porridge that Goldilocks eats, the conditions are perfect. It's neither too far from or nor too close to the sun. Okay, next. When the sun expands, this zone will move away from Earth, and eventually some of the gas giants and their moons will be in the Goldilocks zone. So here, the solar system. This is our the solar system is our home. A neighborhood of planets, moons, asteroids, and comets that dance in a cosmic ring around our star, the Sun. And while the Sun keeps everything going around it locked in its gravity, it also holds the key to our solar system's future. Okay, so the reason why, look at this. The reason why these planets are aligned in the solar system is because of what? Lee?
Um,
It's because of its
this solar is gravity.
yes,
Gravity.
gravity. So the reason why we can stand here on the ground is gravity. So imagine without gravity, I think we're just floating. if you happen to watch some movies that they are in the outer space, most of the astronauts floats in the air. Okay, so our time is already over. So any questions, Lee?
I don't have a question.
Okay. So thanks, Lee, for coming in my class tonight. Have a good sleep and bye bye for now.
Thank you. Goodbye. Have a good night.
You as well. Thank you. Bye bye.
Bye bye.